So we left off yesterday with example G, where we had a trapezoid. We were getting ready for H. What kind of a shape is H? What kind of a shape is H? Is it a parallelogram? Is it a trapezoid? Is it a rhombus? Is it a kite? Is it a triangle? What'd you say? It's a rhombus, yes. What is our formula to find the area for a rhombus? Yes. Yep. 1/2 times, it's diagonal, not diameter, but that's okay. Diagonal 1 times diagonal 2. Now looking at this picture, I need the distance from here all the way down to here. But that's not what I have with this 6 millimeters and this 7 millimeters. 6 millimeters is the distance from here to right here. So how big would this section be? Another 6, yes. So diagonal 1 would be 6 plus 6, or 12 millimeters. What about diagonal 2? We have from the center over to the right corner is 7 millimeters. So how big is this section here? Another 7 millimeters, yes. Thank you. So diagonal 2 would be 7 plus 7, or 14 millimeters. All right, so we can take that and substitute it into our formula. The area for a rhombus is 1/2 times diagonal 1, which is 12, times diagonal 2, which is 14. Grab a calculator and type that in. Tell me what we get. 84. So the area of this rhombus is 84. What kind of units should we put with that? Millimeters squared, because it's area. Every single time we have area, it's always squared units. All right. What kind of a shape do we have in I? A kite. What's our area formula for a kite? Same as the rhombus. 1/2 diagonal 1 times diagonal 2. How big are my diagonals? 16 and 9, and they're showing me from corner to corner, so I don't need to double it like I did on part H. So the area of this kite is 1/2 times 16 times 9, which gives us what? How much? 72. What kind of units should we put with that? Inches squared. 72 inches squared. Perfect. Absolutely beautiful. All right, let's go look at number 4. Number 4 says one diagonal of a kite measures 22 inches. If the area of the kite is 92 square inches, what is the length of the other diagonal? So I'm going to start with my formula. The area for a kite is 1/2 diagonal 1 times diagonal 2. It tells me the area of the kite is 92 square inches. So I'm going to put 92 in the place of area. So 92 equals 1/2. One of the diagonals is 22 inches. And the other diagonal, we don't know. In the picture, they've called it X, so I'm going to place an X there. So I have 92 equals, I can simplify this part right here. What is half of 22? 11. So 92 equals 11x. And then we divide both sides by 11. What do we get? 8.363 inches for our other diagonal. Nicely done. We can turn over to page 3. And try another problem that is very similar. In rhombus ABCD, AE is 7.3 inches. If the area of the rhombus is 96 square inches, find X and the length of each diagonal. So if this right here is 7.3 inches, how big is this? 7.3 inches, yes. So I can find the size of one of the diagonals. One of those diagonals, that would be diagonal AC, would be equal to 7.3 times 7.3, or plus 7.3, sorry, 7.3 plus 7.3, which would be how much? $14.6. We would put inches with that. That's one of the things they asked me for. So now I know how big one of the diagonals is. What is our area formula for a rhombus? Yep, times diagonal 1 times diagonal 2. 1/2 times diagonal 1 times diagonal 2. It says the area of the rhombus is 96 square inches. So we're going to put 96 in the place of A. So 96 equals 1/2. We found the size of one of the diagonals. It's 14.6 times diagonal 2. So now just like we did on the last problem, we're going to take half of 14.6. What is half of 14.6? 7.3. So 96 equals 7.3 times D2. We're going to divide both sides by 7.3. And what do we get? 13.15 inches. Thank you. Not squared. This is a diagonal. Area is squared. Linear measurements are not squared, but I'm glad you caught that there. This is for diagonal BD. All right. So from B all the way down to D, this much right here is 13.15 inches. What do I need to do to find X, which is just this part? Divide it by 2, yes. X is equal to half of diagonal BD so x is equal to half of 13.15. What is half of 13.15? 6.575, and we would put inches with that. Nicely done. Number 6, if one diagonal of a rhombus is twice as long as the other diagonal, and the area of the rhombus is 841 square meters, what are the lengths of the diagonals? All right, so let's draw this picture. There's my rhombus. I know it's a rhombus because all four sides are congruent. And then we're going to draw in the diagonals. Here's one of my diagonals. And here's the other diagonal. One of my diagonals is twice as long as the other. So this diagonal right here, I'm going to say that that's x units big. If that's x, and the other diagonal is twice as big, then how big would this diagonal be? 2x. And in a rhombus, you guys have already told me the formula is 1/2 diagonal 1 times diagonal 2. We have the area. The area is 841 square meters. So we're going to put 841 in the place of A equals 1/2 times x times 2x. And now we're going to simplify this. 841 equals, I can multiply the numbers together. What's half of 2? 1. And then I can multiply the x's together. What is x times x? Nope, that's x plus x. What is x times x? Not just x. What is x times x? X times x is not x. What is 3 times 3? 9, not 6. That's 3 plus 3. Again, that 2x is x plus x. That's 2 times x. X times x is not 1. What do we call it when we take something times itself? Squaring it. So what is x times x? X squared. There we go. So I have 1x squared equals 841. So that's the same thing as just x squared. How do I get rid of the squared on the x? Square root it. And if you do it to one side, you have to do it to the other side. So the squared and the square root cancel each other out. What is the square root of 841? 29. All right, so one of my diagonals, we're going to call it diagonal 1, would be 29 meters. The other diagonal, diagonal 2, is equal to 2x, so that would be equal to 2 times 29. What is 2 times 29? 58, so 58 meters. Nicely done. All right. Let's try another one that's kind of like that. It says the area of a kite is 920 square centimeters. If one diagonal is 3 times the length of the other diagonal, what are the lengths of the diagonals? So the first thing we're going to do is draw our kite. And then we're going to draw in the diagonals. I'm going to call the light blue one diagonal 1, and that's my shorter one, so I'm going to let it equal x. I'm going to call the larger one diagonal 2, and it says one of the diagonals is 3 times the length of the other diagonal. So if my shorter diagonal is x, what would we call the bigger diagonal then? 3x. What is our area formula for a kite? One half. Yep, times d1 times d2. We know that the area is 920 square centimeters, so we're going to take 920, put it in the place of a. So 920 equals 1 half. Diagonal 1 is x. Diagonal 2 is 3x. And just like before, we're going to multiply the numbers together over here, and we're going to multiply the x's together. What is half of 3? 1.5. And x times x? X squared. All right. Now to get x squared isolated, we're going to divide both sides by 1.5. What is 920 divided by 1.5? You said how much? 613.3 repeating? Equals x squared. And then we need to get the x by itself. I don't want it to be squared. So what do I need to do? Square root it. And if we do it to one side, we have to do it to the other side. So the squared and the square root cancel each other out. Over on the right, I need the square root of 613.3 repeating. 24.764. How many threes did you use when you did the 3 repeating? You only use 1. It's a repeating 3, so you need to put more than 1 3 in there. So you're very, very close. You get 24.766 when you use more than 1 3 there. I used 3. Because I usually round things out to 3 decimal places. We usually never want to do less than 3 decimal places unless the directions specifically say otherwise. All right, so what were we having represent x? What does x mean in our problem? It's diagonal 1. Diagonal 1 then would be 24.766 centimeters. Diagonal 2 is 3x. So that would be 3 times 24.766. What is 3 times 24.766? 74.298, yes. And we would put centimeters with that. Nicely done. All right, let's look down at number 8. It says the area of a trapezoid is 960 square feet. If the length of one base is 24 feet and the height is 32 feet, what is the length of the other base? So just like before, we're going to start off by drawing a picture. We're going to draw a trapezoid. So I need two bases that are parallel. And then I need slanted legs to connect those two bases. It says the length of one base is 24 feet. I don't know whether that's the top base or the bottom base, but for the purposes of my problem, it doesn't really matter. So I'm going to let it be the top base. So we're going to call this 24 feet. And then the height is 32 feet. Remember, the height goes from one base to the other and makes a right angle with the opposite base. And that would be 32 feet. Our area formula for a trapezoid is 1/2 height times base 1 plus base 2. So we're going to take the area of the trapezoid, 960 square feet. We're going to put that in the place of A, equals 1/2. And then I can substitute in my height of 32. And then inside the second set of parentheses, I have base 1. Well, one of them is 24 plus base 2, which I'm just going to leave as B2. All right. These two numbers, there's no pluses or minuses in between them. They are being multiplied. What is half of 32? 16. So I have 960 equals 16 times 24 plus B2. I'd like to get rid of this 16 out in front of the parentheses. What operation is happening between the 16 and the parentheses? Multiplication. And how do we undo multiplication? With division. So we're going to divide both sides by 16. What is 960 divided by 16? 60. So I have 60 equals 24 plus B2. I don't need the parentheses around the 24 plus B2 anymore because that's the only thing on that side of the equal sign. Then we're going to subtract 24 from both sides. And what is 60 minus 24? 36. So 36 feet is equal to the second base. We've got 2 more problems left to go for today. Let's look at number 9. The area of a trapezoid is 756 square inches. If the length of one base is 20 inches and the length of the other base is 12 inches, what is the height of the trapezoid? So again, just like before, we're going to start off by drawing a picture of a trapezoid. So 2 parallel bases, and then slanted legs to connect them. Tells me the length of one of my bases is 20 inches. So that's my top one because that's the smaller base. And the other base is 12 inches. Oh, so 20, sorry, 20 goes on the bottom then. My bad. And 12 goes on the top. Somehow I got it mixed up in my head. All right. And we want to find the height. That would be the distance between my bases, making a right angle with the opposite base. There's my height. So the area of the trapezoid is equal to 1/2 times the height times base 1 plus base 2. In the place of the area, we are going to put 756. So 756 equals 1/2 h times B1 and B2 are 12 and 20, and it doesn't matter which one I put where because we're adding them together. Because I don't have any variables inside the parentheses, that's the first thing I'm going to simplify. What do we get when we add 12 and 20 together? 32. So 756 equals 1/2 h, and then inside parentheses, 32. We've had a couple of other problems like this. I have these two numbers here. All of this is being multiplied together, so I can multiply my numbers together. Half of 32. What is half of 32? 16. So I have 756 equals 16h. And then to get h all by itself, what do I need to do? Divide both sides by 16, yes. What is 756 divided by 16? 47.25. What kind of units should we put with that? Inches. It's height, not area, so it would just be inches. Remember, when we are finding area, it's inches squared, but if we are finding something else, it's not going to be squared. In this case, we're finding the height, not the area. All right, very last one. If the area of a triangle is 40.5 square meters and the base is quadruple the height, then find the lengths of the base and height of this triangle. So my first question is, do you guys know what quadruple means? Yes. This means to multiply the height by 4. So I'm going to draw my triangle. I know that it's wider than it is tall because the base is quadruple the height. So if I let the height right here be called x, how big would the base be then? 4x, yes. Our area formula for a triangle, we had 2. We had 1/2 base times height. And we had 1/2 AB times the sine of C. Do we know how big any of the angles in this triangle are? Do we know how big any of the corners of this triangle are? Do we have degrees? That's not one of my corners. Do we know how big any of the corners of the triangle are? Again, do we have degrees? No, we don't have any degrees, so we do not have an angle inside this triangle. That means I cannot use 1/2 AB sine C. We're going to have to use 1/2 base times height. And we know what the area is, don't we? What is the area? Yes, the area is 40.5 square meters. So we're going to put that in the place of A. 40.5 equals 1/2 times my base, which is 4x, times my height, which is just x. Over on the right, we're going to multiply the numbers together. What's half of 4? 2. So I have 40.5 equals 2. And then we're going to multiply the x's together. What's x times x? X squared. So 40.5 equals 2x squared. We're going to divide both sides by 2. What is 40.5 divided by 2? 20.25 equals x squared. And then we're going to square root both sides. The squared and the square root cancel out on the right. What is the square root of 20.25? 4.5 equals x. And what was x representing in this picture? The height. So the height is 4.5. Should we put units with that? Close. Nope. Did we find area? Did we find area? No, we found the height. So should this be squared? No. Just meters, yes. And then my base is equal to 4x. So 4 times 4.5. How big is my base? 18 meters. Very nicely done. And we actually have 10 minutes left that you guys can get working on your homework. Homework is due tomorrow. I am more than happy to help answer questions, but I do want everybody to pull that homework out and to start working on it until the bell for the announcements rings.